Can black holes be destroyed? Black holes are like cosmic vacuum cleaners that suck in everything, even light. They're incredibly dense and have extremely strong gravity, making them very difficult to destroy. However, there are a few ways scientists think they might be able to get rid of a black hole, or make it less dangerous. Hawking radiation. Stephen Hawking's theory of Hawking radiation suggests that black holes aren't completely black. They emit tiny amounts of radiation due to quantum effects near their event horizons. This radiation results from pairs of virtual particles, constantly popping in and out of existence near the black hole. Occasionally, one particle falls into the black hole, while the other escapes. Over time, this process causes the black hole to lose a small amount of mass and energy. This process is extremely slow, especially for large black holes, and for practical purposes, it would take many times the current age of the universe for a black hole to evaporate significantly. It's important to note that this process doesn't completely destroy the black hole, but rather causes it to shrink over an extremely long time. Black hole mergers. When two black holes come close to each other and merge, they can form a larger black hole. This process doesn't destroy the black holes. Instead, they combine to create a single, more massive black hole. This has been observed indirectly through the detection of gravitational waves by instruments like LIGO and Virgo. While it doesn't destroy black holes, it does change their form and can lead to the release of a significant amount of energy in the form of gravitational waves. Information paradox. One of the most intriguing and contentious aspects of black hole physics is the question of what happens to the information that falls into a black hole. According to quantum mechanics, information cannot be lost, but general relativity suggests that black holes can destroy information. Resolving this conflict could potentially provide insights into how to destroy black holes in the sense of understanding the ultimate fate of the information they contain. Various hypotheses and theories, like the holographic principle and firewall paradox, are being explored to address this issue, but it remains an ongoing area of research. Exotic matter and high-energy methods. Exotic matter and high-energy methods are speculative concepts in theoretical physics that could potentially be used to manipulate or interact with black holes. These ideas are mostly based on mathematical models and theoretical constructs, rather than practical, real-world technologies. Here's an expanded explanation of these concepts. Exotic matter. Exotic matter is a hypothetical form of matter with unusual properties, particularly a negative energy density. Negative energy density means that it would have repulsive gravitational effects rather than attractive ones, which is in contrast to the normal matter we encounter every day, like planets and stars, which have positive energy densities and attract each other due to gravity. One of the most well-known forms of exotic matter is called exotic matter with negative mass. If it were to exist, it could potentially be used to counteract the gravitational pull of a black hole. By placing this exotic matter near a black hole, it might create a repulsive force that could, in theory, keep the black hole's event horizon from engulfing objects. However, it's important to note that exotic matter remains purely theoretical and has not been observed or created in the real world. The existence and properties of exotic matter are subjects of ongoing scientific speculation and debate. High-energy methods. High-energy methods refer to the idea of using extremely powerful and advanced technologies to interact with black holes. These methods often involve manipulating the fundamental forces of nature on a scale far beyond our current capabilities. One idea is to create or manipulate wormholes, which are hypothetical shortcuts through space and time. By connecting to distant points in space, a traversable wormhole could potentially allow for the escape or even the destruction of a black hole. However, the concept of creating and stabilizing wormholes requires exotic matter with negative energy density, and as mentioned earlier, such matter remains theoretical. In some speculative scenarios, scientists have considered using incredibly high-energy particle collisions to alter the structure of a black hole or even cause it to evaporate more rapidly through Hawking radiation. This would require technology and energy levels far beyond what we can currently achieve with particle accelerators like the Large Hadron Collider or LHC. In summary, while there are theoretical concepts and processes that might eventually cause changes to black holes or their information content, they are largely speculative and not yet proven. Black holes are incredibly stable and hard to alter, and the timescales involved in any potential changes are typically on the order of billions to trillions of years, making these processes largely irrelevant on human timescales. Thank you for watching, and please subscribe to the channel.